Alrighty, we're going to look at the interacting natural processes that have created the caves on the headland at Muriwai coastal environment. So the caves that are on the headland on Otakamedo Point. Now, the caves are actually situated on both sides of the headland. So we've got some on the Muriwai beach side and we've got some on the Māori Bay side. If we go back to the slide here and we have a look at it, I'll explain the processes that have created these caves. So the first process that I like to talk about in the creation of caves is the climate processes. So that is those winds, those southwesterly winds that are blowing across the Tasman Sea for a 2,000 kilometre fetch. All right, so you've got 2,000 kilometres of undisturbed wind blowing on the ocean that there transfers that energy into those waves. Now we know that the waves that crash at Muriwai Beach have an energy between 2,500 kilojoules and 300,000 kilojoules, and that has come directly from that wind. So that energy has transferred from the wind into the wave. So that is an interaction number one. When that wave comes and is refracted around the headland, so remember they come in their wave trains in that southwesterly direction, they're coming up, but we've got these little bits of land that are sticking out. So the waves bend their energy. So the waves are coming in and they're bending. And when you look at this map, you can see exactly where the energy is getting transferred. And that's where our first wave process of wave pounding comes in. All right, so if you look here, and if you can imagine, you've got your wave coming in and you've got your solid rock, that wave's coming in with all that energy, it is slamming into that rock time and time again. That 250,000 to 300,000 kilojoules of energy is being transferred into the rock, all right? But the rock's not moving. So it is hitting against a wall with all of this force, and that is what wave pounding is. It is waves after waves and force and energy being transferred into the headland, all right? So we've got that happening. But what that wave does to transfer that energy is it finds these little areas of weakness. Now, if you have a look here, you can see the different layering of the rocks, all right? Now, this here is, we know, our Manukau breccia conglomerate. So that is that mixture of andesite and basalt volcanic rock. Very, very hard rock. It doesn't erode very easily. But that's not the only type of rock that is in our headland. We also have a little bit of piha conglomerate, which is our sedimentary rock, all right? That is our easily erodible rock. And these are the lines that you can see. So we can see areas of weakness where those bits of rock have all been compressed together over those millions of years, all right? So rock, the geology element, all right? So what happens is that wave pounding, that wave refraction has bent, the waves are bent to the headland, they're smacking into the headland. Air is sometimes in these little cracks and crevices. When that wave smashes on in, that air has nowhere to go but further into the rock, introducing process number two, hydraulic action. So that wind, that air is just being pushed further and further in, and then when the wave recedes, the air goes back out with it. The wave comes in, the air is pushed further in. What's happening there is little bits of rock are becoming weaker and weaker and weaker, and that structure is starting to break. The little bits of rock are starting to fall away, and with our caves. So once we get a bigger cave from all that hydraulic action happening due to that wave pounding, we start to see here that the water is actually going inside the cave. This is where those little bits of rock and sediment and pebbles and stuff that's fallen away due to that hydraulic action comes into play, because now we get attrition, all right? So another wave action. So we've got attrition happening now too on the sides of the caves. Attrition is those little bits of rock, little bits of sediment mixed in with the water and rubbing up against the side of the rock and pulling away more as well. So it's sort of like filing it down, so to speak. All right. So those are the processes that create our caves, which are on either side of the headland. All right, so we've got climate transferring energy into our waves. We've got waves interacting with our geology. So we've got wave pounding first, transfer of energy. Second, we've got hydraulic action, all right, pushing that air into those cracks and crevices and those areas of weakness, forcing them out, making them bigger. And then we've got attrition, the little bits of rocks rubbing up against the side of the cave, creating it and making it bigger. Radio, I hope this helped you. So that is caves.